Salutations! Today we're going to be looking at the 2012 AMC 10B, problem number 14. And because this is a geometry problem, I'd like you to take some time to look at it and get a diagram out. And then I will show you the diagram from the AOPS website, The Art of Problem Solving, because drawing it here would be just really hard. Okay, so let's look at the problem. Two equilateral triangles are contained in a square whose side length is 2√3. The bases of these triangles on the opposite side of the square. Well, that's very not descriptive. Now it's descriptive. The bases of these triangles are the opposite side of the square, and their intersection is a rhombus. And now what is the area of the rhombus? So the square side length is 2√3, 2√3. And the bases are the opposite side of the square. Okay, we have that. Intersection is a rhombus. So these would be the same. These two would be parallel, and these two would also be parallel. So that's a bit too many markings. And so to find the area of the rhombus, we could, in school you would have learned, like, this is the base, and then this is the height, and then you would do it that way, multiply the base and the height, but that is a bit hard in the context of this problem. So let's do something else that we can do without having to tilt our heads all the time. So first let's find this length of the intersection, I guess the width you could say. But first to do that we must find this, which is the height of the triangle. So the height would touch at the midpoint, so it would be square root 3, and then this would be 2 square root 3 because it's an equilateral triangle. All sides are the same. And to get from this side to this side, we will multiply by square root of 3 to get 3. Wonderful. And for the other triangle, let's switch to another color, magenta, probably. And we can see that this height is also going to be 3. And we're given that the side of the square is 2√3. So now we can do 3 plus 3 minus this. There's overlap, let's call it x. The overlap, let me use the highlighter. Overlap, we'll call that x, and we're going to subtract that from 3 plus 3, which is 6, to get the overlap, which will make sense shortly. X, and then that equals 2 square root 3. And now with some simple algebra, we can make easy work of this. So negative x, negative 6, 2 root 3, and then we negate everything. So we'll end up with that. So this long thing, this green strip over here is going to be 6 minus 2 square root 3. Actually, I'll write it on the bottom because I'm going to mark something on the top later. So that is the overlap. We're going to clear some space over here. And now the second length we need to find is this over here. Oh, wrong tool. Is over here. Now, why that? Why not this length over here? Well, it's because we can take these two triangles and move them up here, so we can get a rectangle. Because all of these 4 triangles, 1, 2, 3, 4, are congruent. Therefore, we can move them like that. We have a rectangle. We have the base. Now we just need that height. So let's clear that and solve for the height. So let's see, this would be half of the green area. I mean, the distance, so it would be 3 minus square root 3. And to get here, we must now divide by the square root of 3, because to get from here to here, we had to multiply by square root of 3. So let's do that right now. 3 minus square root of 3. It's going to be square root of 3 minus 1. So this height over here will be square root of 3 minus 1. Wonderful. Now we multiply these two together. So now we're going to have 6 minus 2 root 3. And then times square root 3 minus 1. Now using our multiplication trick of FOIL, we're going to do first one, so it's 6 square root 3, and then this one, negative 6, and positive 2 root 3. And that will simplify to 8 root 3 minus 12 for this rhombus area. And sure enough, that is an answer choice D. And we are done.